Hello, everybody. I'm here today with Mustafa, the founder of Celestia, and I'm very honored that he came to my On Gelato podcast. So thank you very much, Mustafa. Looking forward to our conversation today.
Hey, yeah, it's great to be here. Looking forward to it.
Thank you. So actually, today, as always on the Gelato podcast, it will be a very technical conversation. I think we will mostly cover technical topics about Celestia's roadmap, the perspective that Gelato has from a rollup as a service provider perspective, and then also our ABC stack, the Abundance ABC Sovereign Rollup stack, which is actually championing one of the concepts that I think you and some other people at Celestia really invented, this sovereign rollup idea, which I will talk about later, but I got pilled heavily. Or heavenly even pilled, I guess. And yeah, but before we go to sovereign rollups and these topics, so let me quickly pull up the Celestia roadmap here. And I think that's where we can start the conversation. I don't think we have to go deep into every detail of it, but it was, I think, last October or September last year that you published this roadmap blog post. And we have the abundant block space. We have the abundant block space, which is basically big blocks, right? The mammoth blocks, and there's some other things in there, like I think verifiability and so on. I mean, verifiable block space in and of itself is a category here, and then frictionless block space. You can briefly touch upon where you guys are at now, like 6 months after this post, and what your focus is this year still. Is like any of this focus, has any of the focus shifted here? I think you recently had some upgrades, right? Lemongrass was one of them and so on. So I guess the question is, like, how big will the blocks get this year on mainnet, on Celestia? And then one thing that I definitely want to double click on is ZK accounts and this Lazybridging topic and so on. I know there has been a working group, and yeah, we're all eagerly awaiting a release there so that we can maybe see if we can finally add some tier bridging to Celestia, right? So yeah, let's start. I shared the roadmap here for listeners on the screen. I will unshare it at some point in the conversation, but yeah, how about you tell us where you're at on the roadmap now and what you still will do this year?
Sure. So you can kind of think of the Celestia roadmap as a three-legged stool. So, like, because there's basically three main core components of this Celestia roadmap, and it's basically like a three-legged stool because all three components of the roadmap are necessary for Celestia to be interesting, or for Celestia to actually serve its purpose. Just like if you take away one of the legs of a stool, it collapses. So obviously the first part of the roadmap, which is arguably the most important part, is this idea of abundant block space. And for that, we want to achieve one gigabyte blocks. And that's simply to, like, you need abundant block space to enable use cases that just aren't possible before with low throughput chains. Like, there's many use cases that require high throughput inherently. And that's why people are deploying rollups in the first place. And the second component, which is verifiable block space, which is this idea of it should be possible to run a light node anywhere, because instead of running a wallet that just connects to some centralized RPC endpoint like in Pura or Alchemy, like that's kind of like against the whole ethos of Web3. The whole point of Web3 is that end users should be able to interact with blockchain without having to trust middlemen. And the idea with verifiable block space is, what if we can integrate a small blockchain node into every wallet so that every user can interact with the chain directly rather than going through the centralized middlemen? And that's very important because that's the whole point of Web3. Like, that's what differentiates Web3 from Web2. So you have abundant block space and verifiable block space, but those two things aren't really useful without this idea of frictionless block space, because you also want the block space to actually be easy to use for developers so that you can actually have useful applications on top of it. And that's where this idea of ZK accounts and Lazybridging comes in, because one of the biggest disadvantages of a modular blockchain architecture is that because bridging UX is so bad, it basically means that if you want to deploy your own like app chain or rollup and have full control over your stack, you have to accept trading off access to users and liquidity. And that's not something you have to trade off if you deploy on Solana. So you kind of like have to try to eliminate that trade-off with this idea of frictionless block space, and that's where Lazybridging comes in, which is like, let's make bridging so easy that using multiple rollups feels like using one chain. And so that's basically the three main parts of the roadmap. Now, for the first part of the roadmap, which is 1 GB blocks or abundant block space, I think we're making very good progress on that. Right now on mainnet, the Celestia throughput, the Celestia block size is 8 megabytes, which is only 1.3 megabytes per second. And that's not a lot, obviously, but we recently, the current bottleneck for that was the Tendermint block propagation protocol is very inefficient. But we've created a new block propagation protocol called Vacuum that eliminates that inefficiency, and we're releasing a testnet for that quite soon. Well, we released a testnet, we released a devnet a few months ago that showed that can achieve up to, I think something like 40 megabytes per second of throughput. So now we're kind of like working to productionize that this year, and that should give us a 5 to 20x boost in throughput.
Wow, cool, nice. So yeah, let's actually talk a bit more about this. I mean, the throughput increase. How many megabytes are we then talking about in terms of block size?
Yeah, so with the Mammoth Mini testnet that we announced a few months ago, that was about 40 megabytes per second. For the block size, if I remember correctly, that was around 80 megabyte blocks, because a 1 gigabyte block target is kind of like it's a weird target, because the real target is megabytes per second. Mm-hmm. So when we set that 1 gigabyte block target, that was when our block time was 12 seconds. So that roughly equates to 83 megabytes per second of throughput.
Cool, nice. Yes, so for this part of the Celestia roadmap, the throughput, the bandwidth is usually actually one of the keywords here. Celestia is like a DA and consensus bandwidth provider for rollups, right? I think you guys also have this tagline, like the broadband moment for Web3 or something like this, where it's like in the early internet days, we had dial-up modems and DSL at some point, and then broadband, and then of course fiber. I think fiber is like this 1 gigabyte and beyond moment for Celestia, if you want to draw that sort of marketing analogy. But yeah, like in a way, I look at Celestia as this almost like this new decentralized internet service provider for the verifiable web, right, that we're building. I don't know if that analogy sits well with you, but like that's somehow also what pulled me a little bit. Now, of course, we can get into the details of what is Celestia actually doing, right? It is providing ultimately consensus guarantees and data availability sampling, right? So but yeah, like how do you, like, what do you liken to Celestia to? Like, is there any analogy you can draw to the existing Web2 architecture? Is it like a decentralized internet service provider, or does that analogy break down quickly?
Yeah, I mean, I think there's many different analogies that you could use. I think the one that I use quite commonly is Amazon AWS. I think that's the one I use most commonly, because the reason why I kind of compare it to Amazon AWS is because kind of like before the cloud, this idea of the cloud kind of became popular, which is basically the idea that you can deploy virtual machines. Before then, if you wanted to create a new website or deploy application, you didn't really have that much choice about how you could do it. Back then, you would have to usually use some shared web hosting provider, like GeoCities or DreamHost, if people remember those kinds of things. But the shared web hosting providers were basically like a shared server that everyone can upload their code to. But they were very limited because you were forced to use certain programming languages and database systems like PHP or MySQL. Like if you wanted to use something else like Ruby or Python or Go, you couldn't, because those service providers did not have that installed on their servers. And so if you wanted that, if you wanted that customizability and freedom, you would have to like buy a physical server in a data center, which is relatively expensive compared to just using a shared server. But shared virtual machines and virtualization kind of fixed that problem because it gave people the freedom to be able to have their own server, but without the overhead and the costs associated with having their own servers, because they could basically have their own virtual servers. And I think rollups are very similar to that, right? Because rollups are basically virtual blockchains, in the sense that before rollups existed, if you wanted to have control over your own stack or control over your own application revenue or different kinds of customization, you would have had to create your own layer 1 blockchain from scratch and recruit some validator set, which is a lot of overhead and relatively expensive. But then rollups came along and kind of basically fixed that problem, because a rollup is basically a virtual blockchain, because you could create your own chain and you don't have to recruit your own validator set, because you can just use some shared DA layer like Celestia, and inherit security from Celestia DA layer. And even if your rollup had one sequencer, it was still secure if it's implemented correctly because of fraud proofs or ZK proofs. So in that analogy, I think AWS is the best. Like AWS provides physical infrastructure provides the physical servers for virtual blockchains. Similarly, Celestia provides the consensus layer for rollups to deploy on top of, that they inherit security from.
Yeah. I heard this analogy. I think that's the one that you usually bring to podcasts that I also listened to in the past. And actually, I really like that. That's one of the analogies that hooked me and got me pilled on Celestia even more. And actually, I think it's interesting because I started my rollup journey in Ethereum land with L2s, OP Stack, Arbitrum, Polygon CDK back in the day from the Gelato rollup as a service side. And I think there's this interesting thing where L2s in Ethereum are a very specific kind of rollup. And actually, Celestia is more concerned with the primitive of a rollup without the mention of an L2 per se. And an L2 is coming from this idea you inherit the, like it's all about fraud proofs and ZK proofs very quickly. And it's all about the settlement client on Ethereum and how can you sort of compress your rollup into some kind of proof and have an Ethereum smart contract re-executed or verify that it was executed correctly. It's a lot about state, right? Versus Celestia being a lot about consensus and DA and really about rollups and not L2s per se, right? Of course, you can build L2s with Celestia, but this was like a key unlock for me, that a rollup itself is not an L2. A rollup is just like you said, and I really recommend anyone to really read the Celestia blog posts, listen to Mustafa's podcast he did in the past as well, and this one today, of course. And in general, the Celestia website and documentation are really great. I think you guys have really done a great. You've really done the best way, I think, of explaining what rollups are and what blockchain architecture is, and it's really reimagined, because most or a lot of us come from this idea, like we all started with Ethereum, and Ethereum is a very specific blockchain. It is a smart contracting platform, right? And Celestia is a blockchain for other blockchains, so very different. So it is originally called Lazy Ledger. This idea of Celestia is, what is a blockchain at its core? And actually, a lot of us in this space think, oh, it's basically Ethereum. That's what it is. But no, actually, before Ethereum, you already had other blockchains like Bitcoin and so on, right? And they were doing very different things to Ethereum. And a blockchain at its core is really just a globally distributed, a single source of truth ledger where nodes can agree to the ordering, right? You can think of it as a bit like a GitHub thing where everybody follows the same branch and they have a way of resolving conflicts and so on to arrive at the same main branch, right? Like which is then the blockchain. And Celestia essentially just provides this as a service. Just like you said, like AWS essentially provides a data center as a service in a way, or like that's maybe the wrong way of putting it, but it provides physical hardware that is then virtualized, right? And Celestia essentially provides you like the blockchain consensus and DA, like this is the core property, the core essence of what a blockchain needs to be good at. And you can now deploy your virtual blockchain or virtual server on top of it as a rollup with your own VM and so on. Like, I mean, usually we still use EVM, but so I think this analogy is really good. And yeah, so for people who wonder about Celestia, like the way I look at it as a rollup as a service provider is, it's a great way for your rollup nodes to sync and to come to consensus on what the inputs of the blockchain are, right? Like what is the order list of transactions, and you don't need to create your own validator set on your token like you would with Cosmos, or also with now Avalanche L1s, where you have to essentially create a validator set yourself, a consensus set yourself, and have that secure the blockchain, right? I think Celestia is really excelling at this public decentralized vision of blockchains, where it's like, hey, everybody can share this Celestia validator set, and millions of rollups can share this, thanks to data availability sampling, right? Like we can have this the many blockchains share the same blockchain essentially, because Celestia provides this high bandwidth. And you get this security and this decentralized consensus mechanism from Celestia. Like you rent that from Celestia, and so it's super efficient, just like you rent your server space from AWS nowadays normally, right? And it's that has economies of scale, and yeah. So I think that's a great analogy, and really excited for Celestia to scale to 1 gigabyte blocks. Going from there to, so just quickly touching on the verifiable block space, like you mentioned, abundant block space, huge block space is meaningless if it's not decentralized. And I think Celestia here also does a very different trade-off to Ethereum, where Ethereum, the L1 tries to decentralize at the validator level. Like they care about home stakers and so on, right? Versus Celestia actually is using a version of Tendermint Comet DFT, and I think it says like the main validators can actually be quite beefy. There's a limited count of them, right, in a delegated proof of stake system, but actually that shouldn't matter so much, because we push the decentralized verification to the edges, to the light nodes, and the idea is that your device, like your browser, your wallet, can verify whether the blockchain is correct. And this is very different to Solana or even Ethereum nowadays, where in order to do that, you would need to run a full node, and almost no one does that anymore. Almost everybody uses an RPC service, a trust set RPC service, right? So I think with Celestia, the vision is, hey, the core can actually be decentralized, but not massively. But it's all about making the blockchain cheaply verifiable at the edges, right? Like I guess that's the essence of it, and those are the famous Celestia Light nodes. I don't know, is there anything you want to mention about this for this year, or is that explainer enough? What do you say?
Yeah, I think we are making significant progress on light nodes as well. So like, yeah, as you said, we have light nodes in browsers. So like you can go on the Celestia Block Explorer, like Selenium.io, and actually run a light node in your browser that syncs very quickly. And recently, we've been working with Leap Wallet, which is a popular Cosmos wallet, to roll out embedded light nodes in these in your mobile app, in the mobile wallets, as well as a browser extension. So they already support it for the browser extension, but recently I think we've launched it for the iPhone and Android app. So I think it's showing that light nodes can be practical if they're kind of designed correctly, but there's still a lot of work to do, because even though it's been possible, we've been able to embed the light node into wallets. We need to actually, to make them useful, we actually need to create the read and write flow, so that like when the wallet tries to submit a transaction, or when the wallet tries to read data like the user's balance, the missing step right now is to make sure that the wallets read that data from the light node rather than the RPC endpoints. So that's kind of like what's coming next in that part of the roadmap.
Cool. So reading the data from the network or from the wallets instead of an RPC, right?
Yeah, exactly.
Okay. So right now the idea is, in the first stage, they get the data from the RPC and that they can verify it, I suppose, with the light node. And then step 2 is like they don't even need to get it from an RPC anymore.
I mean, right now they're just running light nodes in the background, but like they're not actually using the light node for anything. It's just like the wallet just have the ability to run light node, but like the light nodes aren't actually being used in a useful way right now. For them to be used in a useful way, you actually have to use it to verify balances or verify data, or submit transactions to them. So that's kind of the next step.
All right, cool.
Yeah.
And I think that's the light node here is there for essentially verifying the consensus of the Celestia, of your rollup, essentially, right? That's the one part where for me it always breaks down a little bit. Maybe you can help me understand it. There is so with ABC, the abundance sovereign rollup EVM stack that we will also talk about later. We actually have gigagas throughput already, so we have these I mean, not super beefy, but still like beefy EVM rollup nodes, right? And I think when your rollup is using Celestia, technically, if you don't want to trust an RPC anymore, you would have to both verify Celestia locally, like with your light node, I suppose, and then technically you that gives you the blockchain you know, like I guess the state of the consensus layer, and then you still need the execution and state of the actual rollup execution layer, right? So you need both. So I mean, you could get the second part by then running a rollup full node, right? Which might be easier to run than a Celestia full node. I don't know. But and of course, at some point, I guess the end game is you have ZK rollups, and now you can have a ZK execution-like client, and you get a ZK proof from the rollup execution. You get the light node DA sampling or whatever it is from Celestia, and then you really don't need an RPC provider at all anymore. So yeah, how do you think about that?
Yeah, I mean, yeah, they say like that. Yeah, I mean, the user would have to. Ideally, every user of a Celestia rollup runs a Celestia light node, and then, as you said, they would also have to verify the consensus of the rollup. But how you do that depends on what kind of rollup it is as well. Like, let's assume it's a sovereign rollup, and there's different ways they can do that. The way I think the most practical way that I would anticipate that it should be done ideally is using ZK proofs or fraud proofs. So, and this is, for example, what the Sovereign SDK does. So you can create a ZK proof or a fraud proof that if you go through all the Celestia blocks, this is what the state of the rollup is, or this is what the latest block header or state root of that rollup is. So in that sense, the end user would not have to run some kind of beefy node for the rollup. They can just get a ZK proof to know that the rollup, what the latest state of the rollup is. And having these proofs will also be essential for the Celestia Lazybridging story, because Lazybridging relies on ZK or fraud proofs to know what the latest rollup state is, to be able to process deposits and withdrawals to and from that rollup to Celestia.
All right, cool. Yes. So essentially, once you have ZK rollups and especially ZK sovereign rollups are interesting because they don't technically work like Ethereum ZK L2s, which would post a ZK proof to some settlement smart contract, and the only reason to have the proof is so that Ethereum, the L2 bridge smart contract, can verify the rollup state. Versus on a ZK sovereign rollup, you don't post these proofs anywhere on chain to a so-called settlement layer, but you still gossip them off chain in your rollup node network. And now the cool thing is, yes, now an application off chain can consume this proof, and you don't need to run a full node anymore in the application, like, or use an RPC, right? You can. I mean, I guess someone would still serve you the data of the rollup, but you don't have to trust that that thing. You can verify that the data you see is correct with the ZK proof, I suppose, right? Is that the idea?
Yeah, exactly. But I mean, how are you thinking about that how are you thinking about that in terms of ABC stacks?
Yeah.
Design, like, do you plan to support proofs at some point, or what's your thinking there?
Yes. So, okay, I guess we can dive into what are sovereign rollups, right? And ABC stack. So, I mean, first of all, you should check out my Twitter article that I released recently. It's called The Sovereign Pill. You will find it on my Twitter handle, Luis, LUIS_0x. I think that's my handle. So yeah, I posted that the Sovereign Pill article on Twitter recently, and actually, I knew about Celestia for a long time. I was always very interested. I got more interested in Celestia as we were researching rollups like 2 years ago and launching our rollup as a service. But I saw it more as like, okay, cool. This is like a cheap scalable DA layer, right? But there was always from the beginning this concept of sovereign rollups, which you published your blog post on almost 3 years ago now, I think in 2022. So, and I remember following on Twitter back then, like seeing this debate about sovereign rollups. I think it was hotly debated maybe like in the summer 2 years ago or something. But yeah, the first time I really researched it was 2 years ago. And I also talked to Cem from Sovereign SDK back I met him in Paris. We had coffee, but it didn't really click with me. It was confusing. And for most of our engineers, it was very confusing of a concept. And we really dove deep into it. And so at some point we just sort of lost track a bit of it because we were launching back then, like putting on CDK, OP stack, Arbitrum stack, and so on. And I then did another research sprint with the team like a year ago in early 2024, and I rediscovered Sovereign Rollups. And this time it clicked for me, and mostly because I had so much real experience from launching real production rollups and mostly Ethereum, really just Ethereum L2s in production. And the thing that was weird is actually that most what is the original design of an Ethereum L2? What is the intended design, right? Optimism and Arbitrum and so on, usually they all say, and ZK Stack and so on, they say Ethereum L2s are Ethereum, they're there to scale Ethereum, they inherit Ethereum security, right? That's the idea. So really Ethereum L2s are, for me, a very specific kind of rollup where the sole purpose was to have a trust minimized bridge to Ethereum, the settlement layer, and essentially have all of the rollups asset live or be issued on Ethereum, the settlement layer, and then be bridged into the rollup via that trust minimized bridge, which we know as the fraud proof or ZK canonical bridge. But in reality, what happened on our Gelato rollup as a service is that most of our customers that were using OP and Arbitrum, almost none of them were using the canonical bridge. Like at the very least, sure, maybe to you for ETH the asset, but a lot of them came to us. They didn't even talk about ETH or the canonical bridge. They came to us and said, hey, we want to use layer 0, right? Like we already have this token, it's an OFT, how can we get it on our rollup? Or when they were using the canonical bridge, it was too slow for them. And I mean, the canonical bridge is really like just one directional, I would say, from Ethereum to the rollup. It's simple, but the way back is horrible. For optimistic rollups, it's 7 days. I mean, no one can actually use that. And for ZK rollups, I mean, it's arguably better. It's like 30 minutes, but that's still not usable for an end user. No one will wait 30 minutes, right? So you even with ZK nowadays, absent of instant ZK proving, you still need a market maker usually to give you instant liquidity. So a lot of our rollups also were using would want to use a cross, but actually a lot of them simply used mint and burn bridges, or some of them, like we literally had rollups who didn't need a bridge. We had some rollups that, for example, were running an Arbitrum Orbit stack and they didn't use the bridge at all. There was nothing in there. They just had a rollup native token. Maybe they had some game or something. And this was like, for me, weird because a lot of the Ethereum L2 design is literally just about the bridge. If you look at OP Geth and Arbitrum Nitro and so on, there's a lot of code that does nothing else but handling the synchronization of this rollup settlement light client bridge to Ethereum, right? Like, making sure that the rollup status is posted to Ethereum, finalized, and that the fraud-proof challenge window has passed and this and that, right? So that was like the weird thing for me, which it was just empirical evidence that I saw from our rollup as a service experience. And I'm going to share my screen here quickly again to then show you what baffled me also a bit is if you actually so then I assume this must just be our rollups, like there might be like smaller projects or something. But actually, if you look at the TVS on L2B today, of the top like Ethereum poster children rollups like Arbitrum, Base, and OP, the canonical part here is what is actually like using the rollup as intended via the L2 bridge, and it is like a fraction of what assets are natively issued on the rollups, ergo not using Ethereum, or bridged in via external providers like Layer 0 and Hyperlane and so on, right? And actually, if you look at this, like even Ethereum L2s, less than 50% of the top L2s are actually using the Ethereum bridge. Most of the value that is moved to the rollup is going there via other bridging mechanisms that are not using the L2 bridge, right? And therefore completely sort of sidestepping the intended rollup design, which is like this L2 bridge for Ethereum L2s, right? And so why did Sovereign Rollup suddenly click for me? Because in a very simple thought experiment, can you have a rollup without a bridge to a settlement layer? In a Sovereign Rollup, you can. You can spin up a Sovereign Rollup on Celestia, and there's no bridge there at all. It's just like an EVM chain. You have you can mint your gas token, right? And you don't need you can run a rollup without any bridge. And this is not possible with, for example, OP-Stack or Arbitrum, where you always run the bridge with the rollup. Now, of course, you could configure the stack differently, essentially turning it into a sovereign rollup, but like this is not, of course, what they are intended for, right? So I think this was like interesting, first of all, because we had some use cases where literally they weren't using any bridge. And there it already seems like, okay, sovereign rollup is the right choice, right? Because you don't have any bridge overhead if you don't want it. And then the next step is, okay, what if your rollup is just using USDC? Who is the best bridge for that? Arguably Circle, right? I mean, obviously, because Circle is also the bridge now on Arbitrum, OP mainnet base. If Circle is willing to grace your rollup with their CCTP protocol, then they are gonna issue the USDC asset on your rollup, right? So in a lot of rollups like perp dexes and so on, they just have USDC collateral and so on. They don't need any other asset to be bridged. So again, a perfect use case for a sovereign rollup, right? You don't need this expensive settlement bridge to Ethereum, which also we found at least seems like this is causing a lot of the reason that rollup stacks today or L2 stacks today are still very low throughput, like on the single-digit megagas per second, not much at all, right? And I think a lot of this comes from the fact that they have this bridge, L2 bridge synchronization and fraud-proof mechanism built in, which is causing a lot of overhead and performance hits. And just removing that completely, and with a sovereign rollup again with ABC EVM rollups, and just adding Circle or Layer 0 or Hyperlane as your bridge for the asset that you want, like USDC or maybe your own asset that is already a Layer 0 LFT, right? Again, perfect use case for a sovereign rollup. So I think what really became clear to me is that like Ethereum L2s, I mean, in their name, like they're literally scaling Ethereum. So they're really great for ETH-centric DeFi use cases, ETH-centric use cases in general. As soon as ETH plays a major role in your rollup, and maybe other assets that come directly from the Ethereum base layer, I don't think there are that many, to be honest, but ETH is certainly the main one. Then a trust minimized bridge makes sense, I suppose. But if you don't care about that, like if you don't really use ETH, the asset, much in your rollup and so on, or if you're already fine with Layer 0 being your bridge security model, then I think a sovereign rollup makes way more sense, because you do away with the overhead and cost from the fraud proof or even ZK proof that you don't even use, and now we have this thing that we call a pessimistic sovereign rollup. And this is actually what you talked to me about last year when we met in Dubai and afterwards. And I had some questions for you about sovereign rollups and fraud proofs and this and that, and this confused me about them. And I think what really made it click for me is, hey, you can have a sovereign rollup that doesn't have any fraud proofs or ZK proofs. It's called a pessimistic rollup, because all to verify the chain, you just run a rollup full node and you re-execute everything, right? And this is very much like an L1 works, where on an L1 also everybody runs nodes. Your nodes don't produce any, like they're not synced from another settlement layer where you have to make sure that the state roots are correctly posted and not challenged or ZK proven or whatnot, right? Like this doesn't exist on normal L1s. So that's also why we call our ABC sovereign rollups. Recently we coined the term rollup L1s as a new term. So you have rollup L2s or L2 rollups. These are the typical like Ethereum L2s, like OP, Arbitrum stack, ZK stack. And then ABC is not like that. It's not competing with Ethereum L2 stacks. ABC is a sovereign rollup stack, and we call it a rollup L1 stack. And this is, I think, originally also where Ethereum L2s came from, right? Originally, there were a lot of side chains before we had rollups. And then these sidechain bridges would get hacked. Like the sidechains would connect to Ethereum via a bridge, let's say Ronin, Harmony, all of these bridges, or Wormhole, right? Like Solana. So all of these bridges would get hacked. And that's why I think like Ethereum, like it was coming really from a good space saying, hey, multi-chain is a thing. Let's make sure people can launch their chains as rollups, and let's make sure that they have a security mechanism bridge that is anchored into Ethereum. And that's how fraud proofs and ZK proofs got invented for rollups there, right? Which I think is coming from a good place. But the market is telling us a different story. The market is telling us there's so many use cases for block space and EVMs and so on. That's like literally the new web, right? And a lot of them don't even know or care about Ethereum. And a lot of them also are completely fine with layer 0 security or their own security model, because maybe they don't have billions of TVL or millions of TVL even, right? Or maybe because they say, hey, it's Celestia is giving me enough security already for the ordering of everything, and I can run my own full node here with the rollup and make sure like that I don't accept invalid blocks or something, right? So this idea of a rollup L1, where essentially it's like an L1. If you're Binance and you're connecting to an ABC chain, you will run a full node of that ABC chain today, right? And just like with any other L1, you will, like in this case, the beautiful thing is you will sync the blockchain from Celestia, so you get the decentralization of Celestia. Great, right? And now you just re-execute everything locally on your Binance ABC rollup node, and you make sure that you don't follow an invalid or a malicious double spending chain or something, right? And if somehow there is such a chain, you will just reject it, and that chain will be like hopefully a minority fork, given that all the other honest nodes of this rollup will also run the same algorithm, and they will also reject the invalid chain, right? Just like with an L1. So yeah, I think the cool thing here is that if you don't need a bridge to Ethereum, like if you don't need this light client bridge, Sovereign Rollup is great. You can still have awesome security guarantees from Celestia and your own node. It's like still like a L1 blockchain, and yeah, the whole reason to have fraud proofs or ZK proofs on Ethereum is just so that if Ethereum can very cheaply, in terms of gas expenditure, verify your rollup and release assets or not, right? But if you don't use that, if you use layer 0 or Circle use CCP, then you don't even need that. So that's a very long backdrop to sovereign rollups, pessimistic sovereign rollups. That being said, your original question was, how do we think about ZK with ABC stack? And ABC stack is forward compatible with succinct, with RISC-0 and so on. So like we ran as Gelato rollup as a service, we ran Polygon CDK in production last year with Astar. And we really like everybody suffered through that experience because it was simply like the proving costs were insanely high. There were still bugs. The latency was high. It was just too early. And ZK marketing will always tell you, oh, this time it's ready. We're not going to be at the bleeding edge this time. We're going to wait it out a little bit. I want to see some evidence that, these new ZK clients are actually cheaper, much cheaper, and also reliable in production. And as soon as they are, ABC is very easy to, ABC will also have a ZK flavor very quickly. Yeah.
Yeah, I mean, I think that also aligns with Celestia thinking around sovereign rollups, because the original idea, I mean, the way that the way that Celestia differs from Ethereum is that we approach rollups from a very different angle. Like we see rollups as having a completely different purpose than Ethereum. Like the Ethereum rollup centric roadmap, they see rollups as the purpose of rollups in Ethereum is to scale Ethereum, whereas the purpose of Celestia is just to scale rollups, because we don't see rollups as a scaling technology at all. Like we see rollups as a superior way to develop applications in their own right? And that kind of like goes to the fat application thesis, which basically says that, which is basically the opposite of the fat protocol thesis, which is in the fat application thesis, the application will take more, will control more and more of the stack, and that's kind of like what we're seeing with. As you said, that's kind of what we're already seeing in the market, right? With people deploying rollups. Like people are not deploying rollups on rollup service providers like Gelato to scale Ethereum. They're deploying rollups because they decided that deploying a rollup is the best way to deploy the application. And as you said, most of the TVL in these rollups, or most of the assets in these rollups, are not bridged from Ethereum, but they're native assets or bridged externally from different bridges. And yeah, I mean and I think, like as you said, that the market has already shown that, and that's why I think sovereign rollups are basically the future, in the sense that like people are deploying rollups because they want, like rollups are basically like the new L1s in that sense. But I mean, in terms of the bridging security, I think that's an interesting question. Like right now, a lot of rollups, the external bridges do rely on kind of like these multi-sig bridges, like layer 0 or Hyperlane. And I think it's an interesting question to see to what extent is the market okay with that. Like it seems that the market is kind of fine with that so far. And I think like Circle and Tether are a really good example for that, right? Like if you think about like what is the biggest use case of crypto right now, is basically stable coins. And Circle USDT has a market cap of like $80 billion worth of USD issued, and like and that's basically a one-of-one multi-sig that we have to trust at Tether, for the backing of that USD. And so, and then kind of like as a logical step forward, you kind of think like it would actually make sense, like for Tether to have to be a bridging solution between different chains, like other than just issuing USDT, maybe they should issue like other assets, like crypto assets that are minted on other chains. Like what if they actually have ETH and they issue ETH on Solana, for example? Because if people are trusting Tether and Circle anyway, as basically a one-of-one multi-sig, and for the backing of the USD, then it's an interesting question to see, like, okay, well, if the market is fine with a one-of-one multi-sig for USDT, would they be fine for like multi-sig bridges for crypto assets? And that's kind of like an interesting question yet to be seen. But the flip side of that is also, I think the cat is out of the bag on that, because the flip side on that is that like most of the TVL on Ethereum is still on the ETH L1. I still think big institutions or whales are less likely to kind of deposit funds into L2s if they think that those L2s are way less secure than L1, for example. So I think if the bridges aren't, I do think having the bridges being proof-based does kind of like reduce the barrier for people to feel secure or safe in bridging large sums of assets between rollups. But as you say, I don't think it's going to be like a case where it's going to be like they're going to necessarily use ETH as the settlement layer to purchase proofs, for example. But the jury is out. The jury is still out on that.
Yeah, and so I think in this debate, there's always the market and developers and use cases, and then there's the crypto ethos and what are we here for, right? And I think Celestia has this nice property that it is really trying to scale as much as possible already, where I think Ethereum is right now really in a crisis and quite deficient. But at the same time, I know that you, as a founder of Celestia and your co-founders, like you all still, and many in your team, you really are there to also hopefully enable some of these new killer app use cases that don't even exist today, that are really leveraging crypto's core value proposition of unstoppable censorship resistance, globally deployed and verifiable permissionless apps, right? But I think for me, because I also originally I come, like, of course I run a business in crypto, and of course I'm pragmatic, and of course I won't tell someone what to do. If they want to use Gelato, deploy a rollup and do something, I won't lecture them on how to do that. Now, of course, I will give recommendations. What is the best stack for your use case, in terms of like what you care about and so on, right? But if you say I want to build my rollup around USDC or around this layer 0 OFT, like that's, I think, totally fine, right? So I think on the use cases side, actually, it helps to zoom out. I believe we all come from this very small builder industry where it used to be just about Ethereum, and now maybe it's about Ethereum and Celestia and decentralized rollups and this and that. But I think this is actually super niche right now. Like I believe there's already so many, like for me, this vision of this web is like essentially we're really upgrading from Web 2 to Web 3, which means everybody should come with us, literally almost everybody. And the way I think about this is in Web 2, essentially on the web, you had everybody using HTML, right? HTTP and URLs, essentially, right? And I think in this Web3 stack, the way I think about it is everybody is using HTML, which is like maybe you could call it like EVM bytecode, for example, right? And they're using HTTP, and this is maybe the difference. Like this can come in different flavors. It could be like a layer 0, or it could be like a ZK interrupt thing. But they're and last but not least, like the URLs are basically like Celestia, right? Celestia is the new URL. It's like the resource data locator. And you can find the data on Celestia. Of course, not in eternity. You have to download it, but you can verify that it was there, and a lot of nodes can agree that the resource is there, right? Or was there at least. So and the way I think about it is like in Web 2, we don't ask everyone that is launching an app to on day one for this HTML, HTTP URL stack on day one have the best Cloudflare, whatever, AWS, key store, HTTPS, best, like everything best security, right? Like everybody, no matter if you're a hackathon project, a weekend project, or a bank, you're using the web today, right? So I actually see this similar in Web3, where actually I get super excited about people using EVM rollups, no matter if they are secure or not, right? Like the more people use them, I think the more the standards proliferates, the easier it will be to later on move applications higher up the security ranks, right? So you could start as a sovereign rollup, like an ABC sovereign rollup on Celestia, or maybe not even Celestia, maybe literally like on a Google server, right? Like, but like, and then you slowly graduate. And as your startup becomes more successful, like maybe you code this up in a weekend, right? But as your startup becomes more successful, you will want to trade and interact with other merchants on this internet, right? And they will then impose some restrictions. They will say, I won't like you can't connect with my chain unless you're also on Celestia, right? Like we need to use the same DA here. Or at some point, like, hey, if you want to be part of this payments network or this whatever trade network, you need to follow the same ZK standard here, and you need to be part of Lazybridging and so on, right? Like this is how you can connect to our markets. So I think this is how I see it. Like everybody should use EVM or in like another EVM, let's say EVM for now, and write their applications as rollups and use Celestia, and then you can. The more people use it, the more applications eventually will also be compelled to use max security, upgrade to ZK or whatever it is. Because at some point, if you maybe become such a big deal that you can participate in global trade and so on, these markets will demand it of you, right? But yeah, that's how I think about it. Yeah.
I mean, I think ideally, like the end game should be a world where, like giving your rollup ZK bridge level security, should be so easy that you don't have to think about it. But obviously, we're not there yet. Because, like as you said, like ZK proving is expensive and requires a lot of resources and can be slow. But I think a lot of progress has been made over the past few years. Like just a few years ago, we didn't really have ZK VMs, right? It's like if you wanted to create a ZK rollup or some ZK program, you had to write your circuit, usually from scratch. But recently, now we have ZK VMs, like with RISC-0 and a succinct SP1 prover, and they're becoming faster and faster every day. And then we have companies working on hardware acceleration and proving networks. So it could be possible, like in a few years from now, like ZK proving rollup is so cheap and frictionless that it will just be as simple. It will just be like as easy as enabling HTTPS on your server.
Yeah.
That
would be.
Yeah,
that's what we're all hoping for. Like we went to production last year and it was very far from that world. But I believe normally you overestimate how quickly it is and you underestimate it. Then like you think it's coming quicker or you think it will take longer than it actually takes, right? So for me, roughly speaking, I think we are like This is absolutely made up, but like roughly speaking, maybe 3 years away from this world, maybe 5, right? Something like this. And actually, I think this is interesting because I believe definitely if that happens, and I believe it's very likely to happen, then ZK will probably eat everything pretty much. But interestingly, I think nowadays rollups, even though rollup as a service and rollups on Celestia really bring the cost down a lot. What are you buying? You're buying block space, and you buy, especially from Celestia, you're buying decentralization, right? And very cheap, like very efficient pricing. So the idea, I think I still like rollups today. They cost money, right? And I actually think there might be this other effect where in the beginning, once ZK matures, you will have smaller projects benefit the most from it because they don't have the money to attract layer 0 or Circle to care about them, right? So actually, I think there might be this weird effect where in the beginning, ZK will enable lower the barrier to entry to securely, like maybe you have a couple of $1 million on your rollup, but you still don't want to secure that in some random bridge, multisig, or your own, right? So it's a lot of liability. If you're an entrepreneur, you don't want to have $1 million or $2 million of liability. That might be your runway, right? So if ZK already removes that for you by math, then I think it would be cool because like nowadays to really get a good secure bridging setup with layer 0 or Circle, you have to pay a lot of money, right? So it's actually only available to the well-funded projects. And I think ZK is great because like I think in the beginning, well-funded projects will still have the top bridging providers for some time because they will get used to it and they most likely, hopefully, won't get hacked and they will be quite secure. But I think first of all, it's going to lower the barrier to entry for smaller projects. They can now have one-click ZK. Like I think I'm also thinking about this one-click thing, right? Today, one-click layer 0 is very difficult. Like today you have to talk to layer 0 or Hyperlane usually, right? Like in a Slack channel, you have to get into their slots. They have to care about you. You have to figure out who's running the relayer, who's paying the validators, how many validators, blah, 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 who's running the RPC nodes, commercial agreements, all of this. In the future, you should, if we're talking AWS, it should be a click, right? And I think this is where ZK will shine, where ZK is also enabling this one-click deployment of a rollup, and immediately you connect it with a best security interop to Celestia ZK accounts or other ZK rollups, right? But then conversely, I also think that the big projects like layer 0 and so on, for the set of rollups that they have that are ZK, they will also want to upgrade to reduce their own liability because layer 0 wants to connect everything, right? And like whether you're a ZK rollup or not, right? Like that's how they think. So for the pathways that they are currently securing with multisigs, once these pathways become ZK-ified, they will also have an incentive to upgrade and reduce their liability massively for these pathways, right? So yeah, I'm very bullish on ZK in the long term here. But yeah, it's going to be interesting to see how it pans out. Definitely, I think it will take it will really need to be more production ready and much cheaper and faster for it to become interesting. Before that, I think a lot of rollups will go with mint and burn bridges. Like that's what the market is looking like today. Is more and more you see they want layer 0 OFTs or Hyperlane warp routes and so on. I think yeah. The more rollups you have, the more likely they will need mint and burn bridges instead of like canonical asset bridges because it's just not scalable to have market makers for like 1 million or like 1,000 different rollups even, right? I think across really struggles there. But yeah, that's it.
For sure. Yeah, I mean, even before we go to full ZK proving, we like at least from the Lazybridging side, even before we go to full ZK proving, we expect that most users will use ZK proofs or fraud proofs. So instead of creating a ZK proof for every block, which is expensive, we expect that they will just use ZK proofs or fraud proofs. So they'll only create a ZK proof of invalid blocks. So I think that will be kind of like a good middle point before we get to full ZK security. But obviously, that still has disadvantages compared to just using these multi-sigs, because with the fraud proof system, you have a challenge period, and you can definitely get around that by using intent and solver systems to make the bridging instantaneous. But then you have to have then the solvers will charge you a fee, and so because they need to provide liquidity, and they have to rebalance that liquidity. So it's still theoretically more expensive than just using some multi-sig bridge, right? But or like using some like layer zero hyperlane. But that's also kind of like what we're trying to address with lazy bridging, because I think one of the advantages of Celestia is that because it has single slot finality, and the finality time is much lower than Ethereum, for example. Like Celestia's finality time is 6 seconds, whereas Ethereum's is 5 minutes, and that allows solvers that would in theory allow solvers to rebalance liquidity a lot more quickly, because the optimistic rollups could, in theory, have like lower fraud-proof challenge windows, especially because they're using ZK fraud proofs, which is much faster than a multi-round fraud proof. So you can imagine maybe they can reduce the challenge period from 7 days to like a few hours, for example, or like 1 hour, for example. And that could be that could be like a trade-off. That could just be a trade-off that they make, and that would make liquidity rebalancing for these solver systems much more quickly, and so solvers can charge a much lower fee, and then that starts to become more competitive to like multi-sig bridges. But that's kind of like what we're trying to work towards ourselves, at least from that perspective. But and also I think I mean I think even like using a multi-sig has costs, right? Because you have to recruit that multi-sig, and then you have to kind of like pay them a bunch of money as well, too, because they're taking on a lot of risk, because if they get hacked, then they're potentially liable for all those assets. But as you said, that does kind of like carry a like a risk for the business for people building rollups, because I think like one of the like whole points of rollups, or one of the biggest advantages of rollups, is that it allows you to build an on-chain business with less custodial risk. So I mean, it's kind of like the advantages of building a DEX over a centralized exchange, because you're not custodying user assets. A decentralized exchange can't get hacked in the way that a centralized exchange can get hacked. So it makes business as an entrepreneur much more easier, because you're reducing the risks to your business effectively by using the blockchain. But obviously, to get that, then we need to make proof-based bridging much more practical, and that's kind of like what we're trying to do with lazy bridging. But the way that we're trying to approach it is not the same way that Ethereum is trying to approach it. Like we're trying to approach it like, as you said, like as I said, like the rollup, Ethereum's approach to rollups is that they scale Ethereum. So that's why Ethereum wants you to use proof-based bridging between your rollup and Ethereum, and that's why they want a canonical bridge to Ethereum. But the way that we're approaching lazy bridging is let's try to create a bridging product that people actually want to use, or the developers actually want to use, that can compete with multi-sigs and are potentially better than multi-sigs.
Yeah, and like I think I ultimately always come back to this. It's I think a lot of time, and maybe because of crypto Twitter, people think it's like one solution is the right solution for everything. I actually believe, like in reality, I'm a stark believer in like it's probably clear by now, in this world of like, just like we have probably billions of servers on the web, we will also have billions of virtual servers, right? We will have billions of rollups at some point, right? And I just think that means that they will come in all kinds of shapes and sizes, and there will be a certain solution, or like certain solutions will address specific segments of this the best. And then the question that we should argue about, okay, how big is the value in each segment, right? Like, which is the most interesting segment to go for, right? And certainly, like for me, it always comes back to instant ZK proving is really like what excites me. Anything else is like a trade-off where I think you very quickly end up with, okay, like at least that's what I'm hearing when talking to our users, is like very quickly it's like, okay, actually, if I'm already trading off here, then I might as well just use a multi-sig bridge, because you get these liquidity benefits with a multi-sig bridge, where market maker bridges, I think, are great, because you always have to think about what is the asset that you're holding, right? And it's something like across, when they make markets for you across rollups, so when they provide you with quick fills and they rebalance across the fraud-proof bridges for you, they abstract it for you, right? they usually do this only for a limited set of assets, right? Like ETH and stablecoins, because they are relayers, they have to hold this asset in inventory. Now, if you have like all of these rollups, they will all come with their own weird custom gas tokens. So like if you want to not have layer 0 or Hyperlane be the issuer of said token, right? Like, which is scary, right? Like if that multisig bridge is the issuer of the token, this is how Circle USDC works. This is how layer 0 of these work. That means that if they get hacked, they can technically delete all of the balances from all of the wallets without you even being online on the right, like, or using the wallet, right? So because they're basically the issuer of the asset at this point. The blockchain isn't issuing the asset anymore, right? This bridge is issuing the asset because it's a smart contract, an ERC20 smart contract that has a function there to mint and burn it, and that this bridge multisig can call, right? This is scary, which is why it has to be super secure. But the good thing about it is that they don't have to keep an inventory of this and have the volatility of it and so on, right? And the good thing is they can freely mint and burn it. It's just like balance, right? Like a balance sheet, like accounting. And that is a massive benefit, especially for longer tail assets, because if you want a market maker to service your rollup, first you need to convince them to care about your rollup. This is the same with layer 0 or any of these protocols. But then the hard part comes, which is like they need to have inventory on the rollup, and they need to rebalance that inventory, and they need to usually ask you for a loan because they won't want to hold your shitcoin, right? And be exposed to the volatility. So you need to loan them inventory. And this is actually very heavy duty, right? So I feel like the further you move away from instant ZK, very quickly on the trade-off spectrum, people will flock again to mint and burn and OFTs and Circle USDC. Like that's just what I think is happening. So it's really about this instant proving. But then I still agree that there will be some very high value rollup which say, hey, no, I want a certain amount of assets here on the rollup to not be issued by a bridge. I want a blockchain to issue these, and therefore I'm going to use them as canonical assets. They don't have a mint and burn function. And yes, for this, I will recruit a market maker. So I just think that segment is, I mean, it will have probably a couple of like tens of rollups maybe, but not more, like maybe 15, 20 or so. Yeah. And
yeah,
it really depends on the asset we're talking about, right? Stablecoins nowadays are already mint and burn, and Tether is USDT0 is minted by layer 0, right? And Circle is minted by Circle server. So
yeah, I mean, I think like even in a world where we have mint and burn-based bridges based on multi-sigs, like even without like the fourth proof challenge period, there's still a bit of a delay, right? Because in any case, you're bottlenecked by the underlying block times and finality times by the blockchains. Like you have with Ethereum, you have 5 minutes, for example, Celestia 6 seconds or whatnot. So ideally, I think like even in the end game, like I think like solver should be used to reduce the bridging time, not from like 1 day to 1 second, but from 10 seconds to a few hundred milliseconds across chains. I think that should, in the end game, that should be what solvers are actually used for. So, like in that kind of scenario, like in theory, the rebalancing can happen within 10 seconds. So, and the purpose of the solver would just be to make it so that the end user has a cross-chain experience, that when they transfer assets between chains, it happens in under 300 milliseconds before so it feels instantaneous to the end user. I think that should be like in the end game. That should be what solvers are actually ultimately used for. And I think I think in any case, like that in any case that will be required, regardless of your chain infrastructure. Like even if every chain has like 300 millisecond block times, like you still it will still take a few seconds to transfer assets across chains. And I think in endgame solvers will still be required to really hyper optimize the end user experience effectively.
Yeah, it's an interesting point you raise, and it will be a great segue maybe into one of the last topics for us to discuss today, base rollups. But and by the way, I just want to make sure for the listener, like I'm super bullish on ZK. It's just a question of, is it instant or almost instant, and is it cheap? Because I believe then it's just a no-brainer, because at this point you can have mint and burn bridges that are ZK based, right? It's essentially that. And it's for everyone, it's a no-brainer because you can massively reduce the liability, right, in the system. You don't have to worry about North Korea's Lazarus hacking your, compromising your multisig anymore, which is, I mean, look, multisig bridges, like, it's fucking scary, right? Like, they wormhole and so on, they all had incidents where somehow they did get hacked, even though they had a high threshold of signers. So it is scary, and I really hope that nothing happens there. But yeah, so you mentioned that you might still need a solver, even with, let's say, 5 seconds or 1 second transactions, because to shave off some more milliseconds to give this crazy fast experience. I would say, like, from an end user perspective, at some point, like, I would say 500 milliseconds is probably enough. At some point, you reach a territory where it's just about HFT and the user doesn't even notice anymore. I don't know what the human eye can notice. Maybe 500 milliseconds is like the border there. I don't know. But, like, interestingly, ABC stack, right? Our abundance rollup L1 stack already has, I think, 80 millisecond block times or lower. But of course, now, like, the thing with decentralization is it's always usually a game of whack-a-mole, right? Like, okay, where is the poo, where's the bottleneck, right? And so, of course, in ABC stack today, we have the typical rollup model that pretty much any rollup has today, which is the single sequencer pre-confirmation model, right? So in order to have fast blocks, you essentially the application that you connects to the blockchain talks to our sequencer, the ABC sequencer, and that sequencer is giving you a pre-confirmation, just like an Arbitrum sequencer does, or an base sequencer. And it's making it seem to you like the blockchain is super fast, when in reality, the real blockchain, of course, is on Celestia, and that takes, I think, 6 seconds to finalize, which is already great because Ethereum takes 14 minutes to finalize, right? And because it doesn't have single slot finality. So Celestia is 6 seconds till finality, roughly speaking. That's pretty great, but it's still not good enough for the sub-second user experience that most applications demand nowadays. So actually, technically, if you trust us, our sequencer, you don't need a market maker to come in, I think, to shave off the milliseconds. And like, it depends on how fast the ZK proving is. Maybe what I said didn't make much sense. But yeah, like how do you think about sequencer pre-confirmations? And of course, we always paint this picture of the different use cases, some very centralized. Some of them should still be on Celestia blockchains, I think, but it's like a spectrum. And then, of course, I think what you, as the founder of Celestia, are most thrilled by is like these new use cases of truly global, borderless, unstoppable regulation, sort of arbitraging and so on, applications that cannot be shut down or easily shut down, right? And that for me means, okay, we have to decentralize almost everything, right? Like, ideally, no centralized RPC providers, definitely using Celestia DA. Ideally, it's a ZK rollup, so that everybody can verify the chain with ZK, and you don't rely on multisigs for interop. And yeah, then I mean, ideally, it's also a based rollup, right? So it is not using a single sequencer like we have today with ABC. And ideally, it is using Celestia, the base layer itself, for sequencing. So this is a base rollups is also hotly debated in Ethereum. I think Justin Drake is really pushing for that on the Ethereum side as well. He wants Ethereum L2s to become based and maybe even native. But yeah, how do you think about that from the Celestia side? I can tell you, I've been very excited about it from the beginning. For me, based definitely makes more and more sense. Like right now, 6 seconds is probably still too slow, but once Celestia has 1 second, that can get really interesting. But of course, you also have these tricks like based pre-confirmations or something. So yeah, how do you think about that part of the Ethereum roadmap today? I'm not sure how familiar you are with what they're talking there, and how do you think about it from the Celestia side of things?
Yeah, I think we're definitely also excited about base rollups, but I think for a different reason than Ethereum people are. So I think like Ethereum people are excited about base rollups because it provides a greater alignment with the Ethereum base layer, and it fully inherits the security base layer in a greater way, because it doesn't rely. It might not necessarily, and especially if you have a native rollup, then it wouldn't rely on like multi-sig bridges and so on and so forth. But I think for me, where I find base rollups interesting is like one of the original goals of Celestia is to create a world where deploying a rollup is as easy as deploying a smart contract. Because once Celestia launched, there actually weren't any rollups to service providers. It's like if you wanted to create your own rollup, there weren't even any rollup frameworks back at that time. Like this was before OP-Stack even existed. It's like there were only like universal rollups that were deployed by those teams. Like there wasn't rollup frameworks like Arbitrum Orbit or OP-Stack, right? And that's actually why we had to start. That's actually why we started the Rollkit project, because there was no rollup frameworks at the time. But our goal was like, okay, like that we want to see a world where it's as easy as deploying a smart contract, or deploying a rollup is as easy as deploying a smart contract. And then we started seeing the first rollup as a service providers come along, and then that started to become more and more of a reality. Because now you can just go on Gelato and sign up and just deploy your own rollup, very, very easily. But I think taking that a step further, I think base rollups take that as a step further, because right now, like let's say I was an anon and I just wanted to, hack together some application and just deploy it anonymously on the blockchain. I don't know, maybe it's like some kind of like pump.fun kind of application, and I just want to like deploy it and sail off into the sunset. I don't have to worry about like maintenance of servers or anything like that, or pay some regular fee. That's possible with smart contracts today, but that's not really possible with rollups today. But base rollups make that possible, because you don't have to worry about having a sequencer. You can just deploy. You can just deploy some GitHub repo with your rollup code, and use the base layer as a sequencer. So I think to me that's kind of like what interests me about base rollups. And that was kind of like the anonymous use cases, like truly anonymous developers can now actually deploy applications as rollups, if that makes sense.
Yeah, I'm personally very excited about this. I've originally talked a lot about base rollups through the lens of shared sequencing about a year ago. I also talked to the folks at Espresso. They were building the shared sequencing layer. And then base rollups got introduced to me because essentially I think Justin Drake came along and said, hey, I want shared sequencing for Ethereum, the base layer, right? And like you said, I think the Ethereum motivation is a bit more justifying like their rollup-centric roadmap, which is causing issues in the community, because it's like, hey, okay, obviously the L1 now takes hits and revenues and so on. It's not like a smart contract, whatever application layer anymore. And I think there's a lot of justification coming from that. But ultimately, I think the focus there was on the synchronous composability with the base layer in Ethereum land. Now, I'm actually not so excited about this. I think Justin Drake is really excited about it, and I would also like to dive deeper into why, because I went quite deep with it. I think Espresso initially cared about it, but also basically stopped caring about it. For me, at some point, I looked at it and it was just like the technical complexity was so high, and that I was wondering, okay, like actually, I think rollups are almost like a testament to asynchronicity between servers, like in the web, right? Like the web is very asynchronous, actually. And I think like if you want the Binances and whatnot to eventually be a rollup, they don't care so much about liquidity fragmentation. It's like a skill issue for them, right? So they will get the liquidity to their rollup, right? So this, I think the sync composability, I'm not pilled on it, but actually base sequencing, the reason I'm pilled on it is not because of the sync composability with the base layer, but because of the decentralized sequencing, right? Ultimately, a single sequencer, like what we do with ABC and OP and Arbitrum, like these pre-confirmations, they're just like a UX hack so that the chain can be fast, because users demand that nowadays. But in reality, the purpose of the rollup is to be on Celestia, right, or on Ethereum, and that is like the goal. So if Celestia is fast by itself, then at some point ideally we can remove this single sequencer and pre-confirmations altogether. And now we have what I'm most excited about, which like is this total anarchy style of a rollup where the users send their transactions directly to the L1 again, right, to the Celestia sequencer. And like you said, I think there's some really cool crypto applications possible with this where, I mean, first of all, like you said, again, it's about removing a barrier to entry. In this world, you can now build an application, and you probably still need some type of RPC or data provider, but it's definitely, you don't need a sequencer anymore. And this might be like even a barrier to entry thing where it's very easy to deploy a rollup without talking to a intermediary. But the other side of that is this, okay, truly unstoppable, like, okay, like your sequencer can also not be shut down. Like Celestia is unstoppable, right? It's a true decentralized blockchain, which of course a single sequencer is not even trying to be, of course. It defeats the purpose. So yeah, I also see that in the future, I would say this will be like, there's probably like going to be like a magnificent 7, right? Like there's going to be maybe 6 or 7 or 10 of these massive new killer apps, probably like the global exchanges, maybe a global social network of the future. And I think the end state will be that they will be like a based rollup like on Celestia, where everybody on the world can submit their transactions all the time, and they don't have to be worried about being potentially censored or the sequencer sort of being down or whatnot, right? So yeah, I actually I'm very pilled on this. Talking about block times, then, like I think Celestia is targeting 1 second or so, but like how is that even possible with a chain like Celestia?
I mean, Celestia's block time right now is 6 seconds. It used to be 12 seconds, so we actually cut it in half, and we have single slot finality, which means that the finality time right now is also 6 seconds, which is actually the same as Solana's finality time as well. But we want to reduce that even further. But the reason why we can't do that right now is because if we make the block time too small naively, then it will make it much more expensive to run data availability sampling light nodes, because if you run a light node, you have to download every header. But if the blocks are too frequent, then you have to download more and more block headers, and that makes it expensive for these light nodes. But we have a solution for this, which is this idea of separating sampling from finality. So what we plan to do is introduce this concept where we want to have like blocks every few hundred milliseconds, like let's say every 400 milliseconds, for example. But we only construct the what's called the data square, or the erasure coded data square, every 30 seconds. So, and that basically fixes this trade-off of light nodes, because transactions will have 400 millisecond penalty times, but the end user light nodes, they only do sampling every 30 seconds instead of every block. So that kind of like fixes that trade-off, and that's kind of like what we're targeting in the kind of like short to medium term, that we want to reduce the Celestia block time to a few hundred milliseconds, and then hopefully in that world, if you have a base rollup on Celestia, then as you said, you won't need pre-confirmations, because you will have a few hundred millisecond finality time anyways. But I'm also curious, how do you see base rollups fitting into the Gelato kind of product or vision? Because even though I said that base rollups allow you to kind of deploy a rollup without a sequencer, like without having kind of like infrastructure, it's still the case that with your own chain, like there's still a lot of infrastructure that has to be deployed other than a sequencer. Like, and it also depends on application. That you probably need the RPC endpoint for people to use, and then you also like probably need like something like Block Explorer, or maybe Oracle indexers, and so on and so forth. And so like maybe rollups as a service providers can like still play an important role in base rollups in the future.
Yeah. So the role will definitely change quite a lot. But sorry, I'm getting some feedback from you. Maybe if you.
Oh, sorry, I'll make you.
Yeah. So yeah, the role will definitely change. But I don't care too like I'm not worried or anything about it, because ultimately I think what's best should always win for the space, and I just believe that there will always be a wide array of use cases. I mean, for base rollups, I think Celestia also again has a chance to win the race there, because you guys are actually shipping like crazy, and you will probably like reach that low block time, low finality goal soon. I think Ethereum, for example, they have to engineer some crazy stuff to get around the slow block times, right? Like and there I struggle a bit sometimes with like, you know, there seems to be a lot of trade-off made again with base pre-confirmations and so on. So just to be clear, when you talk about Celestia-based rollups, are you referring to this total anarchy style where users directly submit to the Celestia validators and there's no like subset of validators that are like based pre-confers or something like that?
Yeah, I mean, I'm basically talking about a world where users submit the Celestia is the sequencer basically that users can submit transactions there. I mean, there could still be. I mean, we can still have a world where there's like intermediaries or transaction bundlers. Like even if you have a base rollup, users can choose to submit a transaction to some wholesale retailer of Celestia block space or some transaction bundler. But in the worst case, they can choose to bypass the bundler and submit a transaction directly to Celestia if they wanted to as well.
Yeah. So this is also what I'm most excited about, because that's the simplest form, and it's easy to understand. Okay, I can just submit directly to the Celestia mempool, I suppose. It's probably looking a bit different than on EVM, because of course Celestia is a different blockchain. So yeah, no, like ultimately Gelato is a developer platform, right? So we provide block space in all different stacks, right? Like we have Arbitrum, OP, we used to have Polygon, Avalanche L1s, and ABC Celestia Sovereign Rollups, right? And then various combinations thereof, you know, OP succinct or whatnot, like whenever that is ready. And so I still think that there will be use cases outside of base rollups, because you'll ultimately still like are making some trade-offs there. And then within the base rollup use cases, just like as a developer platform, we just want to help the developer, you know, get started. We have other services like Gelato as account abstraction. We have, you know, we work with various interop protocols and so on. So ultimately, we just want to enable developers to build great applications, and like if they can do that with you, I think there's always business to be made. So yeah, actually, I'm super excited to actually see some real cool decentralized crypto rollups, and if we can actually play have a helping hand in there, that would just it just seems right. And like you said, there's a bunch of like the chain by itself can't do that much. And there's a bunch of ancillary services that are needed on top, that we also sell on top. So yeah, and actually in general, base rollups, sovereign rollups, I actually think there are these really cool use cases. Like interestingly, what we've seen like this past year was that a lot of the use cases we saw were pump fun, right, meme coins on Solana, and AI agents like virtuals. And actually, I think these are perfect use cases for sovereign rollups, or like sovereign-based rollups on Celestia, where you like, for example, with Pump Fun, all of the assets that you're creating, like they're created on the fly. So by definition, they don't yet exist on another settlement layer, right? They're literally created on the fly, which is, I think, perfect for a sovereign rollup, because sovereign rollups shine when you have a lot of native asset issuance on the rollup. And today you have a lot of native asset issuance on base. For example, Kaito's token, the VVV token from Eric Voorhees, like these are assets that don't live on Ethereum, they live on base, right? So technically they're using base as if it's sovereign rollups. So I think actually Pump Fun and virtuals are perfect candidates for sovereign rollups, because they can issue all of these assets that are native to their sovereign rollup. They don't need to come from anywhere else. They don't need a bridge, right? They're just there on the rollup. And these ecosystems usually they have their own token. Like Virtuals has their own token. I'm sure Pump at some point will have their own token. And Virtuals pairs like every AI agent coin that they have, they're paired with their own token, right? So I think in these sort of isolated systems where interestingly, I mean, I'm sure people have a lot of opinions about meme coins or AI agent coins, which arguably are just meme coins. But these are, funnily, these are like real cryptocurrencies, right? Like they are not, they only exist on chain. The liquidity only exists on chain. There's no issue outside of the chain and so on. So actually, I think these are very crypto native use cases that I would be excited to see deploy sovereign rollups where it can be super decentralized even without ZK in the beginning, because they don't need a bridge, right? So you don't have a bridge provider. You just deploy your chainator token. That's your virtuals token or your pump token. That's the execution layer's EVM token, right? And then you create meme coins or agent coins on the rollup, and you pair them in a DEX with your token. And then if you also base on top of that, then there's literally no centralized intermediary at all anymore, right? This is really interesting. Now, of course, if you need USDC, probably like I could also see prediction markets use a model like this. But yeah, I mean, a prediction market, if they want to settle in USDC or ETH or maybe TIA, then of course you need a bridge. But yeah, so I think there will be these crazy decentralized use cases, but ultimately it always comes down to the asset as well. I think in a lot of cases, like what are the assets on the rollup, and that's also a form of centralization, right? So yeah, excited to see what assets we will create and trade. But of course, Ethereum, TIA, Bitcoin are and arguably meme coins and so on, I think are the first real like cryptocurrencies.
Yeah, I definitely think with seeing a shift to applications, like pump that fund and so on and so forth, like they leak a lot of MEV and potential revenue to the base layer. So I definitely think that we are kind of seeing a shift to decentralized exchanges trying to kind of capture more of that MEV. And I think Hyperliquid is a good example of that, right? Like it's kind of Hyperliquid is kind of like the antithesis to pump.fun, because it's like you could argue that pump.fun is not possible on its own chain. But I think like Hyperliquid has shown the opposite. Like you can create your own chain and be very successful in creating a DEX that is not integrated to some other L1, and you can capture the MEV and revenue yourself.
Yeah, I mean Hyperliquid is as well a perfect candidate for a sovereign rollup, because I think they only have stable coins as collateral. Like I think it used to be USDC, and probably I think now it's USDC, USDT probably, and USDE or something like that. So and these stable coins they have right now the best bridges they have are like their multi-sig bridges like Circle CCDP or Layer 0, I think is being used for Tether and Ethena's USDE. So I think that's another use case where sovereign rollups really shine. Because you don't need to enshrine a bridge. Like Hyperliquid doesn't have a bridge to Ethereum, right? So
it has I think it uses Arbitrum L2. I think it has a rigid Arbitrum L2.
Yes, but like I think people call it an L3, but like I think that's sort of meaningless. The only thing that sits in that bridge is USDC, that is already issued by Circle on Arbitrum, and I think they consider themselves to be an L1, right? That's how they brand themselves and so on. And it's like at the end of the day, it's just chains and bridges, right? Like there are no L2s. I sometimes joke in my Sovereign Pill article. Now, of course, like what does L2 mean? L2 means you have a great bridge to Ethereum or to Celestia if you use ZK Lazybridging in the future, right? So I think there's value there for sure. But yeah, I mean, if in that bridge you only have USDC, like at this point, USDC is your bridge provider, Circle, in a way. And I think Hyperliquid probably at some point they will ask Circle to either service their rollup or their chain directly, right? I could see that happening, so that they onboard from.
Yeah, I mean definitely, and yeah, I mean I think we're definitely heading to a world where the concept L1 and L2s. It's not really relevant anymore as a terminology. But I think also the interesting thing about the phrase sovereign rollup itself is that it's like when I first termed that phrase sovereign rollup, when I created blog posts about it, in some way like the phrase itself is almost misleading, because like what makes something a sovereign rollup versus a non-sovereign rollup, it's not really even a technical distinction. It's more of a social distinction, which basically says like your rollup is sovereign if your community believes that the canonical fork choice rule or the canonical chain of your rollup is decided by your community and not by some external bridge. And the more that the value in your rollup is not bridged through that a canonical bridge, then the more it really is. Then the more that's really true, right? And as you said, like with Arbitrum, for example, only 20-30% of the value is bridged through the canonical bridge, and that's the case with like optimism mainnet, for example. And so you could argue like like optimism and Arbitrum are like in theory already sovereign rollups, because
Yes.
like like imagine like what would happen if there was some hack in Arbitrum or optimism mainnet that made everyone lose all their assets on that rollup. They would probably much rather save 70% of the value that is not bridged to the canonical bridge, rather than 30% of the value that is bridged through canonical bridge, if they had to choose between the two, right? In the worst case scenario. So you could argue like, and I think one of the engineers from Optimism has actually already made that argument and said actually Optimism mainnet is already a sovereign rollup, because we can have multiple canonical bridges in anyway, and that kind of like created a lot of controversy in the Ethereum community. Like, no, you don't call yourself a sovereign rollup. You should be Ethereum aligned and so on and so forth.
Yeah. This is exactly the realization I also had, and what I wrote in my Sovereign Pill article. Actually, we will release some data soon. You heard it here first. We will file a motion with L2B to also focus on other metrics. Actually, I can give you a sneak peek of this.
Okay.
So
is it going to be on the L2B's forum?
Yeah, I guess we have to post it there, but yeah, so we essentially, you know how L2B they have these, essentially they only care about these green slices, which unfortunately are completely meaningless, and like not completely, but it completely, like, it depends on the context, right? Like, I mean, famously for 2 years you had this rollup Fuel V1 with the green slices, which like $600 in there, right? Like, and they've been around for 2 years. Somehow they're all green, but they're the last ones, right? Like, so something is wrong here, right? And like the thing is, I think what they miss is essentially these green slices are all about how the canonical bridge is set up, right? Are there fraud proofs? Can you self-sequence this and that? Like, it's all about this L2 bridge mechanism, and to be fair, also DA mechanism, which I think is actually important. But what I said earlier already in the Sovereign Pill article as well is actually it completely depends much more on how many of the assets in the rollup, like the TVS, right? Like how much of that is actually in this bridge, right? Because you can have all green slices, but if 1 billion, like if you have a 1 billion TVS rollup, all green slices, but this 1 billion TVS is coming from layer 0 or Circle, then you're not getting any of the benefit of the green slices, pretty much.
Yeah, that's true.
So
that's a very good point.
Yeah. So actually, just sorry, quickly to finish off here. So actually, we looked at these ratios here. This is just Arbitrum 1, not to single them out, like Base, Optimism, they all look pretty much the same. And you see that this here is the canonical versus external bridges. Canonical is, roughly speaking, right now 43% or 44% on Arbitrum, and the rest of the lion's share of the value is Circle's CCDP USDC. So that is not using canonical bridge, and it's actually all even in the hyperliquid bridge. And then you have a small share coming from Stargate, which is also not the canonical bridge, right? In terms of like, I think this is like ETH and USDC and USDT on the rollup. And then very interesting as well is the volume, the bridge volume. So if you use a cross, you might use the canonical asset, right? Like you might get ETH from a cross, but in transit, as you're moving your ETH from Ethereum to Arbitrum, you're actually not getting the rollup security. You're getting a crosses security, which is they're using some UMA Oracle system or something. So in the volumes ratio, canonical bridge versus external, it even looks worse, right? The canonical bridge now is only 22% of the volume, versus most of it is like, I think like this is USDC and then Stargate and Across actually shows up here as well now. And yeah, then also like a huge chunk of these assets on the rollup are like actually like there's a lot of TVS on the rollup that is also minted on the rollup itself. It doesn't even exist on Ethereum, right? So so I think we will actually file a motion to L2Beat to change the heuristics a bit, and we're introducing this Ethereum settlement score essentially, because for Ethereum L2s that like inherit Ethereum security, and that's the purpose of them, right? Like it's way more, I think, important to focus on these properties and get a score like as to like how much of the volumes and the TVS on the L2 is actually secured by this green slices that I have, right? Like, because otherwise I think it's quite misleading actually in terms of risks. It's very it's quite misleading.
Yeah. I mean, that's definitely a good point. Like, those pies are only relevant for assets bridged from the Ethereum bridge, but it's not really clear when you look at the L2Beats website. That's the case. Like if you're natively minting your asset on Arbitrum, then you don't necessarily care about that pizza chart.
Yep.
Yeah, I mean, it'll be yeah. I'll look forward to that motion to see. So what you're basically proposing a settlement score instead of a.
Yep.
Okay.
Yeah, we will, like for Ethereum L2s. I mean, this is what L2Beat is about, right? Like I think we have to move away from the green slices. We will include the green slices in the weighting. I think they are important to be weighted for the canonical bridge usage, but it will be a mix of weights that also factor in the rollup TVS. Is it coming from the canonical bridge or not? And then the volumes, right? Because like even if let's say you have ETH on your rollup via the canonical bridge, but all of the users bridge that ETH in and out of the rollup via Across, then actually they are quite prone to the risks that Across imposes, right? Which is not the Ethereum fraud-proof risk. Like Across is a market maker. They give you money on the other side, and if their dispute resolution mechanism doesn't work, then you're out of money, right? So even for Across, which are working with the canonical bridges, right? Like even they're in transit. If you don't use the canonical bridge, then you're not secured by it.
Yeah, that's a good point. I have another call in a sec, but
we can actually, we're right on time, so let's end it here. Yeah, thank you very much, Mustafa. Great chat, and yeah, I think there's a bright future for all kinds of rollups, Celestia, Sovereign Rollups, Ethereum L2s, everything. Let's just grow the space together. But yeah, we have to be. I think there's a lot of misconceptions, and I hope that for some technical listeners today, and also maybe non-technical listeners, we were able to explain what rollups are, reimagined, and maybe clarify some of the really, I think, misconceptions about them today. Yeah, thanks a lot, Mustafa, for coming on.
Yeah, thank you for having me. And speak soon. Bye-bye.
Bye-bye.